Hi everybody, we've got another visual pattern challenge for you today. In this one, we've got some hexagons, it looks like, but we're told to count the line segments, not the hexagons themselves. If we were counting the hexagons, it looks like one hexagon, two hexagons, three hexagons. That would be pretty easy. Next one would be four hexagons, but we're counting line segments, and there's a little bit of overlap in the hexagon, so slightly more complicated. But I think you can do it. So if you choose to take this challenge, you'll need to find out how many line segments are in the next step, step 4, and then how many in step 43, and come up with an equation that you could use to model how many line segments are in any step at all. So I'm just going to number the steps. If you choose to take this challenge, pause the video, see if you can figure it out. All right, so let's think about this. In step 1, I've got 6 segments, right? There are 6 sides in a hexagon. In step 2, if I had 2 hexagons that were separated from each other, I'd have 12 sides, but one of them overlaps. So I've only got 11 line segments. So I'm going to actually jot this down. There's 6, there's 11. And then here, well, what do we have? This overlaps, so that chunk is 11, and then this um, overlaps, so that's going to add just another 5 to it. So that should be 16. So when you're not sure exactly what's going on, a useful thing to do is to make a chart and look at the difference between each step. So I'm going to do that. We got step numbers and then segments. So I've got 6, whoops, not 6, we want the step number. In step number 1, I have 6 segments. In step number 2, I have 11. And in step number 3, I have 16. So let's look at the difference between each one. 11 minus 6 is 5, and 16 minus 11 is 5. So it looks like we're going up 5 every time. And I guess that makes sense because we're adding this much of a hexagon, just those 5 sides every time. So if we're going to predict how many in step 4, we'd probably go up by 5, and 16 plus 5 would be 21, and that would be how many in step 4. So I think that's correct. I'm going to jot it down here. We'll test that when we come up with an equation. And that's actually our next task here, because finding how many in step 43, you can draw it all out or count somehow, but I think making an equation first is the best way to get to step 43. So in a lot of patterns we've looked at before, we've seen this constant difference from step to step, and that creates a linear pattern. And a linear pattern can be modeled with this kind of equation, the equation for a line, y equals mx plus b. And in this equation, m, which is the slope for a line, is the rate of change of your pattern. So if we're going up by 5 every time, that's what the m is going to be in here, 5 times x. So we've got y equals 5 times x, and then we just have to adjust it so that it works. This b is some number to just make it all come out. So if we look at the first step, if I put in, so y is going to be our total number of line segments, x is going to be our step number. If I put in 1 for a step number, I'd get y equals 5 times 1. So that would just be 5 segments, and we've got 6 here. So to get up to 6 from 5, I just have to add 1. So that is our equation. But maybe we should test it first. Let's look at step number 2. So y equals 5 times 2 plus 1. Does that equal 11 segments? Well, yeah, 5 times 2 is 10 plus 1 is 11. If we try it in the third one, 5 times 3 is 15 plus 1 would be 16. In the fourth step, y equals 5 times 4 plus 1. Yeah, that's 21. So all of that works out. This is definitely our equation, y equals 5x plus 1. Once you've got that equation, it's pretty easy to figure out step 43, because we can just plug that in for x, the step number 43. So y equals 5 times 43 plus 1. All right, we need to multiply 5 times 43. 5 times 40 is 200, and 5 times 3 is 15. So it's 215 plus 1. So it looks like 216 sides in step number 43. Well, how did it go for you? Did you get those answers? Did you get some of them? Let me know. Thanks, everybody.